In the next problem, we have a truck that's moving east with 10 meters per second, and a truck moving north, a car moving north with 15 meters per second. They collide, they stick together, and they start moving along the path of the final, which makes an angle theta with the horizontal. And we want to find out the momentum. We want to find some velocities here to find out the situation to help the insurer adjuster. So one thing we can say is momentum is conserved even though the two vehicles get stuck. This is an inelastic collision. So we can say that momentum in the x direction initially and finally have to be the same. This means that the mass of the truck times the velocity initial in the x direction for the truck plus the mass of the car times the initial velocity of the car in the x direction has to equal the mass of the truck plus the mass of the car times the final velocity x. And likewise, we can say initial momentum in the y has to equal final momentum in the y direction, which means the mass of the truck times the initial velocity of the truck in the y direction plus the mass of the car times the initial y direction velocity of the car has to equal the mass of the truck plus the mass of the car, since they stuck together, v final y. Notice that this is the momentum of the truck and the car after collision in the x direction, and this is the momentum of the truck and the car in the y direction. So we can say that the momentum of the truck plus car in the x direction is going to equal the mass of the truck is 2,000 kilograms. Initially it was going at a speed of 10 meters per second in the x direction, plus the mass of the car is 1,000 kilograms. It was not moving in the x direction, so that's 0. And we get that the momentum in the x direction has to equal 20,000 or 2.0 times 10 to the 4th kilogram meter per second. Likewise, the momentum in the y direction for the car and truck after the collision is going to be 2,000 kilograms. Now the truck was not moving in the y direction initially, so that's 0, plus 1,000 kilogram times the initial velocity of the car in the y direction is 15 meters per second, and that gives us 1.5 times 10 to the 4th kilogram meter per second. So notice we have now that the momentum of the truck and the car as magnitude is going to be the square root of 2.0 10 to the fourth kilogram meter per second quantity squared plus 1.5 times 10 to the fourth kilogram meters per second quantity squared, which gives us about 2.5 times 10 to the fourth kilogram meter per second. And now the angle, tangent theta, is going to be, or better yet, let's do the following, as we've always done. We can say that theta equals tangent inverse of 1.5 times 10 to the fourth kilogram meter per second over 2 times 10 to the fourth kilogram meter per second. And that gives us an angle of about 37 degrees. And now if we want to find the final velocity, that is the same as the momentum of the truck and the car over the mass of the truck plus the mass of the car, because that's the new mass of our system. And this is the same as 2.5 times 10 to the fourth kilogram meter per second all over 2,000 kilograms plus 1,000 kilograms, which is about 8.3 meters per second. It's a little different way of what we've normally used to do, but it's still a valid method for solving for final velocities.